Good morning, guys. Today we are going to be looking at trigonometry and trigonometric ratios. But before we do that, we're actually going to review some prior skills that we've looked at that are critical to being able to complete these problems. So before we even look at new material, we're going to review some old material. Now, when we're working with trigonometry, we often use right triangles. Now, when we're using right triangles, it's very helpful to us for a number of reasons, mainly because we can use the Pythagorean theorem. We can utilize the Pythagorean theorem. For those of you who don't remember, that's a squared plus b squared equals c squared, where c must be the hypotenuse. Remember, we use this to find missing sides in right triangles. Missing sides in right triangles. So let's look at an example of this. Notice here we have a right triangle. We have one leg being 6, we have one leg being 8, and this side we do not know. If you want to set up the Pythagorean theorem, which is how we find these missing sides, the first thing you want to label is the hypotenuse. Remember, the hypotenuse is always across from the right angle. This is going to be very important when we look at our new topics. Hypotenuse always across from the right angle. In fact, it draws a little arrow there. Now, the reason, again, the hypotenuse is so important, that has to be by itself. That is our C value. Blank squared plus blank squared equals blank squared. I fill in the hypotenuse first. In our case, the hypotenuse is x. So I'm putting x over here. Now, I have 6 squared plus 8 squared. Right? These two sides are arbitrary. You could have those switched. It does not matter. What does matter? This side, the hypotenuse. So 36, or 6 squared is 36. 8 squared is 64 equals, and we just leave this as x squared. We combine our like terms, and we get 100 equals x squared. Now, some of us can run this and do this, complete this square root in our heads, because remember, to get rid of a squared, we utilize a square root. But what we're going to do is, just to review this, I'm going to show you how we do this in the calculator. Now, please make sure if you go into our resources to get you started, I have a video that shows how to open up our emulating calculator here. For those of you, I know most of us don't have one of these at home, and that's perfectly fine. The way we do square root, and make sure you're doing this using the touch screen here. We hit second, and then notice this purple square root here. Whenever you want to use something in purple, you have to hit the second button first. And we hit this button here, and notice it brings up a square root. So I'm going to type in the square root of 100, and again, notice I am using the touch screen, not actually typing in, because sometimes the numbers don't work properly. The square root of 100, we hit enter, is 10. So we have the missing side in our triangle is equal to 10. Let's check out another example. Let's look at this example here. Again, notice it must be a right triangle, so I have a right angle. I know one of my sides is 3. I know one of my sides is 12. We need to find x. Notice for this example here, we are going to do blank squared plus blank squared equals blank squared, where, remember, this side needs to be the hypotenuse. That's our special side. Always draw in my arrow from the right angle. Boom, hypotenuse. Notice the x does not always have to be the hypotenuse. We label the hypotenuse first, then we fill them in. 3 squared, x squared. And again, those two could be switched as well. Make sure, again, the hypotenuse, I cannot emphasize this enough, must be by itself. 3 squared is 9, plus x squared is equal to 144. Now again, we're solving for x. We subtract 9 from both sides, and we get x squared is equal to 135. Again, to get rid of the square, we take the square root. We go to our calculator, second, and then where our square root is, 135. We hit enter, and we get 11.6. These will not always be whole numbers. You'll get decimals plenty of times here. No issues when you are working with decimals at all. It is no big deal. But you got to make sure you find those missing sides. Now our last example, and probably our most difficult today, is going to be the following. Is going to be this example. Notice it looks crazy because we have this here, but do not stress about that. Do not stress about the radical. We're still going to do the same steps. I want you to pause the video and see if you can figure out the hypotenuse and plug it into our equation. Boom, all right, so you paused it. You did it. Across from the right angle, hypotenuse, right? I'm labeling that. 3 square root of 2. 3 and x. Now this side's really easy. 3 squared is 9, very similar to the top, plus x squared is equal to, now this is difficult, or more difficult. To do this in the calculator, make sure you put it in parentheses as squared. And I'm going to show you how to do that now. 3 second square root of 2. And notice here I'm going to the right to get out of it. I don't want to exit the square root, you just hit the little right arrow. And I'm going to close my bracket. And then I'm going to square it. The way you square it is I tend to use the little caret right here. And notice it takes me up into the exponent. And then hit 2. That is 18. Subtract 9, we get x squared is equal to 9. We take the square root, and x is equal to 3. Boom. Nice looking whole number here. So again, Pythagorean Theorem, incredibly important when it comes to evaluating these problems. Make sure you know how to do this before you start looking at the trig ratio problems. Thank you guys so much. Have a great rest of the day. Make sure you watch my other videos.